Oh man. Kind of rough. I had a long, well, not that long, but I did have to work late, which means I got to the gym late, which means I had dinner late, which means I'm now late to this. Oh my god. Have we done it? 9:15. Okay. Um, um, why is that? So what did I do here? The merits of schema. So I took a lot of notes. I didn't write many. Flashcards though. Alright, oh, I think I went too far. Here we go. Oh, forgot to add some stuff actually. Oh man. Um, okay. Need to encode it as a sequence of bytes. We then discussed a variety of different encoding. Yeah, okay, so there is something I thought about today. There's a lot of information here. We went over encoding and decoding, but what we didn't do is recognize. So I didn't recognize this as I was as I was going. Um, but right, it gave me different formats, like this is saying right here. So you have language specific formats, which are rarely used. Because of that, they suck. We have JSON and XML and binary, which are standardized. Then there's binary. So then it's binary encoding. And then we went over binary encoding, and then we went over ABRA, so schemas, right? So, so we should make some flashcards here based on that, right? At least one flashcard for some of this. There was a lot of information here. I guess how much I don't want to. write down implementation specific stuff though, you know? Mm. So what are we doing here? What are we doing? Okay, so let's go back through the sections maybe. So we have language specific formats, right? It's always good to review stuff anyway. Where's so much stuff here. Yeah, here. Okay, so here. Let's add this, and then is it like this? So, so first off, right? Yeah, so, okay, let's start writing this down. God. Because this is important actually. I'm literally like using this at work at the moment. Not specifically JSON, XML, and CSV, but like backwards, forwards compatibility. Like this whole section is actually really relevant. Okay, so okay, so pros, human readable, human readable, universally almost. Cons, Okay, yeah. It doesn't matter how pretty efficient. The difficulty of getting different organizations to agree on. Okay, yeah. Okay, yeah. So great. Can I preview this? I think that's how. Let me double check. Um, Here, maybe here. I should have at least one. Oh, maybe I can actually delete that one too. That's stupid. Um, oh, it's just one question mark. Yeah, see? Okay, so it's just one question mark. We figured that out just there. Okay. No, it's in the same section. Ooh, there. For data that is used only internally, there is less pressure. For example, you could choose a format that's compact and faster to parse. JSON is less. Some of these formats support data type. Otherwise, they keep coded data that is binary encoding JSON. Code username. Ah. Um, binary encoding. That was stupid. That's a bad card. Um, All right, that's a hefty card, but I like it. It captures, I think, most of that section. Avro is just another type of binary encoding. Yeah. So okay. Okay, let's spend 15 minutes on modes of data flow, and then we'll spend the last 10 minutes going over flashcards. Zoned out. At the beginning of this chapter, we said that whenever you want to send some data to another process with which you don't share memory, for example, whenever you want to send data over the network to write it to a file, you need to encode it as a sequence of bytes. We then discussed a variety of different encodings for doing this. We talked about forward-backward compatibility, which are important for evolvability, making change easy by allowing you to upgrade different parts of your system independently and not having to change everything at once. Compatibility is a relationship between one process that encodes the data and another process that decodes it. Yeah, I feel like that's pretty clutch. That's a fairly abstract idea. There are many ways data can flow from one process to another. Who encodes the data and who decodes it. In the rest of the chapter, we will explain some of the most common ways how data flows between processes via databases, via service calls, via asynchronous message passing. Data. in a database, the process that writes to the database encodes the data, and the process that reads from the database decodes it. There are many ways. There may just be a single process accessing the database, in which case the reader is simply a version of the same process sending a message to yourself. Backward compatibility is clearly necessary here. Otherwise, your future self won't be able to decode what you previously wrote. In general, it's common for several different processes to be accessing a database at the same time. Those processes might be several different applications or services, or they may be several instances of the same service, running in parallel for scalability or fault tolerance. Either way, in an environment where the application is changing, it is likely that some process accessing the database will be running newer code and some will be running older code. For example, because a new version is currently being deployed in a rolling upgrade, so some instances have been updated while others haven't. We've talked about this, right? Yeah. This means that a value in the database may be written by a newer version. Oh, I see. So it's talking about even when you're only speaking with the database, the backward forward compatibility is still like a problem. Yeah. Like these are two important. However, there is an additional snag. Say you add a field to a record schema and the newer code writes a value for that new field to the database. Subsequently, an older version of the code, which doesn't yet know about the new field, reads the record, updates it, and writes it back. In this situation, the desirable behavior is usually for the old code to keep the new field intact, even though it couldn't be interpreted. Encoding formats discussed previously support such preservation of unknown fields, but sometimes you need to take care at an application level, as illustrated in figure 4.7. For example, if you decode a database value into a model objects, into model objects in the application, and later re-encode those model objects, the unknown field might be lost in that translation process. Yeah, solving this is not a hard problem, you just need to be aware of it. Cool. This is not something I've ever thought about. I guess I never really thought about encodings that much either. I don't think I even thought of JSON as an encoding. It was just a thing that I've always used. read and decode into model object. Nice. I literally never thought about this problem. Wow. I zoned out. Fuck. Ugh. Archival storage. Perhaps you take a snapshot of your database from time to time, say for your backup purposes or for loading the. In this case, the data dump will typically be encoded using the latest schema, even if the original encoding in the source database contained a mixture of schema versions from your different eras. Since you're copying the data anyway, you might as well encode the copy of data consistently. As the data dump is written in one go and is thereafter immutable, formats like Avro object container files are a good fit. It's a good opportunity to encode the data in analytics-friendly column-oriented formats such as Parquet. In chapter 10 we will okay, so basically the answer is Avro. I am curious, I'm going to Google real quick, crdb encoding formats. Structured data encoding in cockroach DB. This is interesting. We should check this out. So, can I download this? Copy raw file. Is that gonna be the? Let me put this in new note. This work? Kind of. Let me see. Make this big. This doesn't seem like this stuff copied over. Let me compare real quick. So I see 5.1 table ID accounts, and then index ID, primary and column keys. Does it look the same there? Oh, it's actually pretty close. Well, it'll take a second to get there anyway. Oops. Like many databases, Cockroach crdb encodes SQL data into key value. Pairs. The format evolves over time with an eye toward backwards compatibility. This document describes format versions 3 in detail, except for how crdb encodes primitive values. Do I need that too? Oh, this is code. Is this Go? What is this? Yeah, it's Go. Cool. Huh. Okay, so let's go back to Obsidian real quick. Oh, maybe it'll be worth reading these, huh? Yeah. Alright, let's go find those real quick. Okay. Let's open this. How long is this gonna take? It's pretty long, but we can get maybe a screen here for it. Add s. We'll go. Okay. Display window capture, and then Firefox. This one. Okay. Alright, so we're reading this now. 7 minutes? 8 minutes? I thought crdb was it? Oh. One more tweak. There. And then let's. I thought crdb. Oh. In the past, we described CockroachDB as a distributed transactional consistent key value. So I'm reading this because this is what we use at work right now. We knew that a key value API was not the endpoint we wanted to provide. And a few months ago, started work on a higher level structured data API that would support tables and indexes, along with supporting such rich structures. We anticipated eventually supporting SQL for manipulating and accessing the structured data. After a bit of soul searching, we embraced the inevitable and moved forward full speed with SQL as the core of our structured data layer. There are a lot of components to a SQL system: query parsing, query analysis, planning. Yeah, I looked at this today. Query execution, transactions, persistent storage, to name a few. The SQL system is built on top of internal Cockroach key value store and leverages the monolithic sorted key value map to store all of the SQL table data and indexes. This post will focus on crdb's mapping of SQL data to the key value store and show how that mapping helps implement SQL functionality. Future, okay. A SQL table is a set of rows where each row is a set of columns. Each column has associated type, bool, int, float, string. Yeah. Oops, too far. This sounds nothing at all like a key value API where string keys map to string values. How do we map the SQL table data to a key value storage? Okay, so this is interesting. So today I had to do an explain analyze on a query that I wrote, and I noticed that in the join, like the indexes are all key value. Well, I guess that makes sense. I'm an idiot. Maybe I'm not an idiot. They're talking about it and they're saying that, I don't know, whatever. Conditionally set the value of the specified key if the existing value matches the expected value. Retrieve all of the keys between start key and exclusive. Internal key value sorts a number of operations, but we only need to know. Okay. If in CockroachDB, keys and values are both strings, which can contain unrestricted byte values. Key encoding. I said I only have a few minutes left. I said I was gonna do flashcards, but let's not. Let's start touching on this. A foundational piece of the puzzle for mapping SQL table data to keys and values is encoding typed columns data into strings. For example, given a tuple of values, 1, 2.34, we would like to encode this to a string that conceptually looks like, okay, so these are columns, right? Yeah. Oh, we can look at the actual code. Except it's not there. What? Oh, it's old. I forgot this is old. Okay. just zoned out. It's too late. Oh, interesting. So table name primary key type, right? I'm too tired for this. Okay, we'll try. We'll start from up here or something tomorrow. Right on. Oh, I didn't realize that it was monstrously large. My bad. I hate that it does that. Alright.